Alright. So this is going to be the first lesson about adding and subtracting rational expressions. So your objective is that you can add and subtract rational expressions with both common and uncommon denominators. We'll start with common just to make it a little bit easier, and then by the end we will be working with uncommon denominators. Okay? So the warm-up has 3 examples, and I know they're not exactly in this order, but go ahead and do C first, just as a good review. So go ahead and pause it, work through C, and then unpause it, and we'll kind of talk through it. Okay, so if you factor completely, this is what you would get. Notice that when you group these together, it becomes a sum and difference, which is where these two binomials came from. If we cancel what we have in common, we have a 2x minus 3 here and here. We have an x minus 1 here and here. We have an x and an x squared here, leaving us with an x. And then that's it. So in the numerator, we're left with a 2x plus 3 times an x plus 1. In the denominator, we're left with an x times an x plus 14. Alright. So yesterday we kind of talked about these two examples over here. So let me reiterate. We always want to find the least common denominator, meaning the smallest number that they have in common. We can make 6 and 9 both become 18. So I'm just going to put an 18 over here so you know that that's what we're trying to make them. So I can make 6 become 18 if I multiply it by 3 over 3. Remember, that's multiplying by 1. Over here, I'd multiply by 2 over 2. So that makes this 3 times 11 is 33. This 2 times 1 is 2. Okay, so there's my numerator, both of which are over 18, which then equals 35 over 18. Okay, which cannot be simplified. There's no common factor that either of those numbers have. Okay, 20 and 12, let's see. Think about, so I always start with the biggest number and kind of think multiples of it. So if I think like, okay, there's 20, the next multiple would be times 2, which is 40, times 3, which is 60. Can I make 12 become 20? No. Can I make it become 40? No. Can I make it become 60? Yes. So 60 is my least common denominator. So I multiply this by 3 over 3, and I multiply this by 5 over 5. So 33 over 60 minus 25 over 60. So 33 minus 25 is 8 over 60, which can be simplified to 4 over 15. Okay, so that's the idea with a common denominator. So now let's go work with some expressions. Okay, we're going to start with some common denominators so we can just kind of talk through what we do with the numerators. Okay, so notice that these have the same denominator and we are subtracting. So 7 minus 5 gives us 2, and then denominator stays the same. Don't actually add or subtract the denominator. We can simplify this. 2 and 12 we can divide by 2, which leaves us with 1 over 6x. And that would be your final answer. Okay. Over here we have the same denominator. We need to be very careful though that when we subtract, this is subtracting both terms. So I'm actually going to write that out. So it means we're doing 5x minus 25x minus 10. Okay, so 5x minus 25x is negative 20x minus 10. That expression can be simplified. I can factor out a negative 10. Negative since that's my leading. And that would leave me with a 2x plus 1. And that's all over the common denominator, which is 40x. And I can see that by factoring out that negative 10, I can actually factor these two numbers. And I can divide by negative 10, or just 10. And it leaves me with a negative 1 over 4. So then this simplifies. The negative I'm just going to pull out front. I'm going to say that leaves me with a 2x plus 1. There's my negative sign over 4x. Okay, so this would be my final answer. Don't do anything with those x's. This binomial does not match that monomial. All right. Okay, let's try another one with the common denominator. In this one, again, I have common denominators and I'm adding. So adding makes it a lot easier. I don't have to worry about distributing it. So I have a 6x squared, an 8x, a 12, and a 9x. So if I put this in descending order, that would be a 6x squared plus a 17x plus a 12. Okay, and now I'm actually going to write this out to kind of emphasize what I'm doing. So here's my denominator. If I can get the numerator, if I can factor it so that it has a factor of 2x plus 3, then it can be simplified further. So in trying to figure out if I can simplify the numerator or factor the numerator, I'm going to start by saying that I want it to be this, and if it's not this, it's not going to simplify anyways. So I'm going to start by saying, here's my two sets of parentheses. I know that I want a 2x plus 3 if it works. So then that would mean that this has to be a 3x because that gives me my 6x squared. And if this is a 3, then this would have to be a 4 because 3 times 4 is 12. So now I want to check and see if that actually gives me my middle term. So these two give me an 8x, and these two give me a 9x. And when I add those, notice I got 17. So it does factor. And it factors over this, which means this cancels, and my final answer is a 3x plus 4. So that's not going to work every single time where I kind of like backwards go through factoring. But if it didn't factor with that 2x plus 3, even if it did factor, if it wasn't that same as the denominator, it wouldn't have canceled and simplified, so it wouldn't have mattered. So I was just kind of checking to see if that worked. All right. All right, the next one, we have a common denominator again already. So if I add my numerators, I get a 2x squared plus a 2. If you notice, I don't keep writing the denominator because I don't want to write the fraction out, then write the fraction out. I'm going to factor this first, and then I'm going to say that this is x squared plus 1. Okay. This can be factored further, but over the imaginaries because of that plus 1. So I'm not going to factor it since there's no imaginaries in the denominator. So if I leave this and have it over my denominator of x squared plus 1, notice that this cancels, meaning my answer is 2. Okay, and again, we won't be factoring over the imaginaries, not with the expressions. Okay? Alright, so flip over and let's talk about some uncommon denominators, or unlike denominators. Oops. Okay. So, we now have unlike denominators. So, over here, so I always list them out. I have a denominator of a 5 and a denominator of an x. There's nothing I can do with those to make them the same. So, the only option I have is to multiply them by each other. So, over here, I'm going to multiply it by x over x. And over here, oops, x over x. And over here, I'm going to multiply it by 5 over 5. Okay, making my least common denominator 5x. Okay, so x times 3 is 3x. Notice this is a plus 2, so I'd circle that so you know. So positive 2 times 5 is positive 10. That cannot be factored anymore, so then I'm going to write it over my denominator of 5x, which means that's my answer. Okay, so that was pretty painless. Over here, I'm going to want to start by actually creating a fraction, so writing it over 1. I have a denominator of x plus 1 and 1. They do have a 1 in common, but this is part of the binomial, so there's nothing that I can make them look alike. Making them look alike usually happens like yesterday, where something is like a 2 times an x minus 1, and the other one has an x minus 1. So those binomials match, and then I can make them both have that 2. Okay, so that's what I was getting confused. So in this case, the only thing that I can do is I can make them have a least common denominator. Notice if I multiply 1 times x plus 1, I get left with x plus 1. So this is my least common denominator. Okay, so I would put it, like I'm doing right now, I would write it and put a box around it. That way you're thinking, okay, I need to make both of these have that denominator. Well, this first fraction already does, so this is the only one that I need to multiply and change. So I'm going to multiply by x plus 1. So my numerator of 5 stays the same. And then over here, I need to take a positive 3 and distribute it. So I would circle the plus 3 and show that you're distributing. So that gives us a positive 3x plus 3. Okay, there's no need to write it over the denominator so that I have to keep writing stuff. I'm going to combine first. This gives me a 3x plus 8, which cannot be simplified any further. So that's over my denominator of x plus 1. And then that would be my final answer. Okay, it's a little bit harder to add and subtract and change fractions and for them to cancel. It can happen, it's just a lot harder. So a lot of times things won't simplify further. Okay, let's try again. Okay, I have two binomials. I have a denominator of 2x plus 1 and a denominator of x minus 3. There's no way that I can make these look alike. They don't really have anything in common. So my only option is to multiply them by each other. So this becomes my LCD, which means if this one already has the 2x plus 1, then I'm going to multiply it by x minus 3. And since this one already has the x minus 3, it's going to get multiplied by the 2x plus 1. Okay. I want to make sure that I multiply the 3x and distribute it to both of those. So that leaves us with a 3x squared minus 9x. I want to make sure I take this positive 8 and distribute it to both, so I'd be circling that, which leaves us with a positive 16x plus 8. Alright, if I combine like terms, I get 3x squared plus 7x plus 8. Okay, I could try to factor it I really want it to be one of these two binomials. If it's a 3x squared, I know that the only way that it's going to factor is if it's a 3x and an x. It's a plus and a plus. Okay. It obviously can't be this 2x plus 1. Maybe it's that x minus 3, but then I look at it and go, well, if that's x minus and both of these have to be plus signs, even if this does factor, it's not going to cancel over here. So you really are done with the problem. We could try to factor it. Let's see. I can't put an 8 here. Put an 8 here. That's not possible. I can do a 4 and a 2. That's 6. So that doesn't work. So it's not factorable. So that means then I would write my answer as 3x squared plus 7x plus 8 all over 2x plus 1. And again, you can multiply this if you want, it's just not necessary, so I would leave your answer like this. So that is the most simplified. Okay. Alright, in the next one, so again, I want to start by listing out those LCDs, or sorry, denominators, so I can determine what the LCD is. They don't have anything in common. If this is a monomial and this is a binomial, so that means that the least common denominator will be to just multiply them by each other. Right now, that's kind of like our only option, just to kind of make it easier on you guys, but you will have least common denominators where you can change them. Okay, so I'm going to multiply this one by 4x over 4x. I'm going to multiply this one by x plus 1 over x plus 1. Okay, now would be a really good time to pause this and see if you can kind of go through this problem and unpause it and then see how you did. Good test to see how you're doing. Okay, so if you're checking your answer right now, this 3 needs to get distributed to both of those. So that becomes a 3x plus 3. Be very careful here that you pull that minus 1. I would circle it so you don't lose it. So negative 1 times 4x is negative 4x. I can combine like terms here. 3x minus 4x is negative 1x plus 3. I could factor that. I could factor out the negative 1 and make it x minus 3. My common denominator. So the whole point of listing it out here is that now I know what that denominator is. It's a 4x times an x plus 1. Nothing cancels, so this would be my simplified answer. Okay. Alright. How many more do we have? We have 2 more. Okay. In number 9, so the first thing I want to do is notice that there's a GCF here. Whenever there's a GCF in the denominator, I want to make sure I factor it. So that denominator would be 4 times k plus 3, and my other denominator is k plus 3. Notice that both of these have a k plus 3 in common, which means that they already have that in common. Then the only thing that I could do to this one is I can multiply by 4, and I can make them both look like this. Okay, so the nice part about that is this denominator over here, so I'm actually just going to write it underneath it, already looks like 4 times k plus 3. So I don't need to do anything to this first fraction, but this fraction over here, I need to multiply by 4 over 4, and now it looks exactly like this. Okay, so my first numerator is actually going to stay the same at 6k. And then I want to make sure that I have a minus 5 times 4, so that would be a minus 20. I can factor a 2 out of this, making it a 3k minus 10. And that's all over my least common denominator, which was 4 times k plus 3. Okay, I can see that these can be simplified. That cancels, and this becomes a 2. So my numerator is 3k minus 10 over 2 times k plus 3. And that becomes my simplified answer. Okay. Alright, in the next one, so this one I might be able to help start, and then you might want to try it on your own. Okay. Alright, if I list out my denominators, I have 3 of them this time. I have a denominator of x, x squared, and 2x. So, just like we've been doing in other problems, you want to approach numbers and variables separately. So, this is a 1x, and this is a 1x squared. So that means for my numbers, one denominator has a 1, the next one has a 1, the next one has a 2. So that means I can make all of them have a 2, because I can multiply 1 by 2 and it becomes 2. This has 1x, this has 2 x's, and this one has 1. So that means all of them can have an x squared. So this is my least common denominator. So I need to make every denominator look like this. Well, this first one, in order to look like that, has to be multiplied by a 2 and an x. So a 2x. And then this is where I want to make sure. So a 2x times x gives me a 2x squared, so that's good. And the next one, in order to make it look like a 2x squared, I need to multiply by a 2 over 2. The next one has a 2x, so it needs to be multiplied by an x over an x. Okay, so it's really important that you guys double check to make sure that all 3 of those denominators are this least common denominator. Otherwise, even if I do the multiplying right, I'm still not going to end up with the right answer. Okay, so just to make sure, this gives me 2x squared, this gives me 2x squared, and this gives me 2x squared. Okay, and then because of that, now I can multiply the numerators. So if I multiply these two, I get a 4x. If I multiply this positive 3 times 2, I get a positive 6. Okay, and if I multiply, it's kind of hard to see now. If I multiply this negative 1 times x, I get negative x. Okay, so let me kind of get rid of some stuff so you can see. So this, let's take these out. Okay, so now you can see. We multiply the 2x times the 2 to get 4x, multiply the positive 3 times 2 to get 6, and pull the negative 1 times x to get the negative x. Okay, so instead of writing it over my denominator so I don't have to keep writing the same thing again and again, I'm going to combine first. 4x minus x is 3x plus 6. This can be factored. I can factor 3 out, which leaves us with x plus 2. Okay, and then that's all over the least common denominator, which is a 2x squared. So nothing can be factored any further or simplified any further, so that becomes our final answer. Okay, you need to go back and listen to anything again. Go back, listen, see if you can kind of figure out what's going on here. If we kind of look forward to your homework, oops, that's not the right one. Okay, so this will be what your homework looks like. You're going to have common denominators. Common denominators, just pay attention to negative. And then I think there's a couple more that have common denominators like this. You're just going to have to pay attention. These are not common denominators. Alright. But yeah, so like if you have one like this where it's a 3 and a 5w cubed, 3 and 5, the only thing that you could do is make them 15, and then you can make them both have a w cubed. So if I wanted 15, that means I'd have to multiply this one by 5 w cubed, and then over here I'd have to multiply this by a 3. Okay, I want to double check if I multiply those together, that would give me 15w cubed, and if I multiply these together, that gives me 15w cubed. Make sure your denominators are the same, so that then you make sure that your numerators make sense, okay? If the denominators aren't the same, then the whole problem is going to be wrong anyways. Okay? On the back side, you're going to have some with common denominators, some not, and then this is with you in number 10. The only other thing is pay attention to number 8. When you list out these, you can make a 4 and a 6 both become a 12. Don't have to make it become a 24. Like 24 is always the common number that I see when we multiply them together. Okay, so not this. Alright, if you have any questions, come see me Friday morning. Alright, good luck.